0. Hello and welcome to Mr. McLaren's Math World. This is the way it is. Logarithmic equations using any base, part 2. So let's have a look at some of these. Once again, really the important thing here is to understand the structure of a logarithm. To realise that 6 to the power of x is equal to 1. Now we happen to know from an index law that anything to the power of 0 is 1. You could say, if you wanted, that 6 to the power of x is equal to 6 to the power of 0. Anything to the power of 0 is equal to 1. So here, quite clearly, x is equal to 0. Okay, what about this one? Well, again, it's very unusual to have a base of a half, but anyway, half to the power of x to the power of x is equal to 2. Now we could say, if we wanted, that this is equal to, this is one way of doing it at any rate, isn't it? Because the right hand side is simply, whoops, I left off the x there. The right hand side is simply equal to a half. Using that well-known index law. And we could say that that's equal, anything to itself is that thing. So half to the power of 1 is a half. So in this case, x is simply going to equal 1. Okay? Let's have a look at this one. You couldn't kettle a fish, this one. What we might have to do here is add log base 10x to both sides. And thus we would get 3 equaling log 10 2 plus log 10 x, log base 10 x. And so using that log law we saw quite a while back, we would say 3 equals log 10 to x, isn't it? We multiply those to get to there. Okay, so now what? So we're going to say 10 to the power of 3 equals 2x. Therefore, 1,000, because 10 cubed is 1,000, equals 2x, and therefore x will equal 500. Okay, so that's that sort. To the next page. What have we got here? Well, we're going to make use of the index law we made use of in the previous question. And that is to say, we're going to say, therefore, log base 5, the base is the same, so I can do this, x plus 1, bracket x minus 3, probably should all be in square brackets, equals 1. Now, what have we got here? Well, we can say that 5 to the power of 1, which is 5 of course, but I'll put the index in there, equals x plus 1 times x minus 3. And expanding, what we are going to have is a quadratic equation to solve. So therefore, and let's put the 5 on the other side, using FOIL we've got x squared minus 3x but plus 1x is minus 2x minus 3 equals that 5 there. So what we're going to do now is subtract 5 from both sides so that we can solve for x. Therefore, x squared minus 2x minus 8 equals 0. Now we're going to use the product sum number routine to solve this. Our product is 1, because the coefficient of x squared is 1. 1 times negative 8 equals negative 8. And the sum is negative 2. And the numbers have got to have something to do with 4 and 2, don't they? Remember the hints here. One of them's got to be negative, because a negative times a positive is a negative. And the larger in 2 must be the negative one, because we've got a negative sum. Okay, so let's just check that negative 4 times 2 is that. Yep. That plus that is that, correct. So we can say from here that x minus 4, x plus 2 equals 0. Solving for x, we get x equals 4, changing over a bit, or x equals negative 2. Okay, now let's just have a look at our solutions there. I can see that x plus, if x was to equal negative 2, would I have a problem? Well, certainly negative 2 plus 1 is negative 1, and that wouldn't exist. So that's a problem there, and it's a problem here as well. I have negative logarithms, and we know that we can't have that. If I substitute 4 in, not a problem at all. So we would ignore or cut out that solution. We would say x minus 2 is not a solution. Therefore, x is equal to 4. Okay, can you stop the tape, please?